Okay, let's look at this question related to Lewis structures. So the question is to draw the Lewis structure for SeCl3+. So to do this, it would help if I had a periodic table, which I happen to have right here. So let's take a look at it. Okay, selenium is right here. Chlorine is right there. So now I can use a little trick to figure out the number of valence electrons based on where these elements are in the periodic table. Okay, so things in this family tend to have 1 valence electron, 2, 3, 4, 5, 6, 7, and 8. So selenium should have 6 valence electrons. Chlorine should have 7. So now that I know that, let me go back here. So I have 6 valence electrons from selenium, and I have 7 from each of the chlorines, but there are 3 of them. But I also know that the thing has a charge of +1, which means that it lost an electron. So I'm going to subtract 1 from that. So I have 21, and 6 more is 27, minus 1 is 26. So now I have 26 total electrons to play with. And I want to try to plop these into the appropriate Lewis structure. So the first thing to do is to put an atom in the middle. And the central atom is, generally speaking, the one that's written to the left of the molecule. So in this case, the selenium. And then we connect the selenium to the chlorines by using single bonds, like that. So each of these single bonds is really a pair of electrons. So if I keep track of what I had 26 electrons total. I used up 6 because I have 3 bonds, each of which is 2 electrons. That leaves me with 20 electrons. Now I distribute the electrons to the outer atoms so that they have a stable octet. So that means that this chlorine is going to get 6 more electrons, so it can add up to 8. This chlorine is going to get 6 electrons, so it adds up to 8. And this chlorine gets 6 electrons, so it also adds up to 8. So that means that I used up 18 of my electrons. I have 2 more. Now I have to give them to somebody. The somebody is going to be the one in the middle. So I'm going to distribute those to the central atom. So I have 2 more over there. Now I'm down to 0. And to kind of finish this up, I'm just going to write brackets and then a plus sign around the whole thing. And what you can do as a little check to see if this is meaningful or not is to figure out the formal charge for each of the atoms. Okay, and so for selenium, formal charge, for any of these actually, is equal to number of valence electrons minus the number of bonds that I have minus number of non-bonded electrons. So selenium has 6 valence electrons. It's making 3 bonds, and it has 2 valence electrons. That means that this is going to have a total formal charge +1. And all of the chlorines are identical, so I just have to do this once. So for Cl, I have 7 valence electrons. I have 1 bond, and I have 6 non-bonded electrons. 7 minus 6 is 0. That's perfect, because that means that when I add up all the formal charges together, I have 1 plus 3 times 0 is +1. And notice that it all has to add up to +1, because that's the overall charge on my ion. But I was also able to give all of the atoms the smallest formal charge possible and still add up to +1.